Zhiyao. I go by Lucius. I am 17 and I am a rising senior at Los Osos High School. And I worked on this project with my partner Jonathan Thamram from the California State Polytechnic University. And this is an intelligent computer application to correct posture in exercises using human motion tracking. Okay, the application in which the research paper which the research paper revolves around is called FitPose. This was created in the Python coding language, and FitPose aims to correct and better one's posture in exercises by utilizing artificial intelligence and machine learning. Specifically, in this case, motion tracking was used to assess and give feedback to the user about their exercising form to help the user correct their posture. Uh, this program utilizes the OpenCV library as the primary component of processing power behind the motion tracking in this program. OpenCV, which stands for Open Source Computer Vision Library, is a library of programming functions for Python, C++, Java, C, and assembly language. The current available exercises in FitPose is the bicep curl, push-up, plank, and the downward facing dog. Although I do hope to add more exercises into the future. And down here, this is just a general layout of how the application works, where you start with the splash screen to home screen with the given exercises, and then it takes you into a analyzer where it will utilize your front-facing camera and then track your posture through motion tracking. Now, my inspiration for FitPose comes from my passion for exercising. I've played many sports in the past, and I've always been a huge fan of exercising for a healthy lifestyle. I'm also huge on self-improvement. I believe one should always better themselves in some way every day, and exercising is a great means of self-improvement and enhancement. But one of the most key factors in my creating of FitPose is the lack of proper self-assessment for posture and exercising. Like right now, the most common way of attempting to do an exercise is to like search it up on the internet, search up the exercise you want to perform, and maybe you watch a video or read a article about how to perform the said exercise, and then you try yourself. However, when you do this and you're trying to perform the exercise yourself, you often have no good means of properly judging your posture unless you have like someone else who knows about proper posture for the exercise you're trying to do there with you that can assess it for you. Now, this is where FitPose can come in and serve as a form of assessment for one's posture to make sure that an exercise is really done properly. So why does posture matter when exercising? First of all, the effectiveness of the exercise is largely dependent on the posture. The alignment of your body is extremely important when performing exercises, and it is crucial that your body is properly aligned when exercising. Poor posture leads to the exercise not targeting the intended muscles and can cause the exercise to work muscles that you are wanting to rest and can lead to less effective exercising in general. Also, the range of motion is largely affected by the posture. And when exercising in the wrong posture, the range of motion is often altered in a unfavorable way, which once again lowers the effectiveness of the exercise you're trying to perform. Maintaining a good posture also distributes the strain of your workout more evenly and allows oxygen levels throughout your body and muscles to be at their highest, which allows you to have more do more reps of the exercise you're trying to do and just be more effective in general. Hence, we need good posture to maximize the benefits that exercise can bring. Another benefit of proper posture in exercises is that it reduces the risk of injury. Proper posture keeps your bones and joints aligned properly. What this means is that it reduces the wear and tear that exercising can create on much of the supporting structures of our body. What this means is less risk of energy or injury, I'm sorry, in both the short term and the long term. In the short term, there is less risk for muscle and tendon tears and ruptures, sprains of ligaments, and many other types of injuries. In the long term, there is less risk for chronic pains in various areas such as the back and shoulders, less risk of tendinitis and kidney damage or even failure, and so on. Just in general, it is much safer to have correct posture in order to reduce the chances of having these type of injuries. Also, good posture during exercises often translates into everyday life. Keeping your body in optimal alignment during exercise carries over to your day-to-day tasks as you get used to being in that good alignment. Exercising in good posture helps you get used to that good posture and alignment and makes it easier to have and maintain in everyday life. It carries over to normal activities such as walking and sitting at a desk, and which can lead to like reduced back pain, reduced joint degeneration, and spinal dysfunction, especially in the long run. Now, how does fit pose correct posture? Fit pose corrects posture through motion tracking of various points on the body, where it keeps tracks of angles between the points which are measured to determine whether the form of the user is correct or not. In the program's analysis training, the program will utilize the user's camera to track the user's motion. The user is to position themselves so that their sides are facing the camera. And here in these photos, you can see the motion tracking component of the program. And in this case, I've selected the plank as the exercise for the analysis of this program. And here you see me doing the motion of a plank, except just sitting up for ease for visibility. The program is keeping track of three key points, um, that being the wrist, elbow, and the shoulder. Then using these 3 points, I fed the code an angle range that is generally correct for a plank, which I found based on a lot of reference videos found on the internet of, for example, fitness influencers and personal trainers and such. In this case, the angle was 75 to 85 degrees. And in here, as you can see, it falls within that range, being at 77, and it returns as good form. Here, 58 returns as bad form. And you can generally see that's not the type of form you want for a plank, while this is much more what you want. So when the angle between the wrist, elbow, and shoulder falls in that range, like it tells you you have the correct posture. When the angle falls outside the range, the program tells you that the posture needs some fixing. Um, I I plan on adding much more specific and tailored feedback in the future to better help correct the user's posture. But overall, the functionality of FitPose revolves around these angle measurements between certain points of the body to determine whether the user has correct or incorrect posture. Now, some exercises would require a lot more points of measurement. For example, the downward facing dog would require a point on the wrist, the elbow, shoulder, the buttocks, knees, and ankle to serve as the key points of measurement for the motion tracking program. And then measuring the angles between the many of the mentioned points in order to determine whether or not the posture of the user is actually correct. Now, here are some current problems with FitPose. Currently, with FitPose, there are a few problems I definitely hope to address and fix in the future. First of all, has to do with the camera, and there can be a lot of camera alignment inconsistencies. First of all, many cameras have like different resolutions, different aspect ratios, and I'll need a way to account for all these factors that could come into play. And right now, just leaving it as is leads to weirdly stretched out videos in some cases in the video analysis part of the program, which can alter the angles between the key body points that are being analyzed. And what this will do is lead to more inaccurate readings, and this will heavily undermine the effectiveness and general reliability of the program. The motion tracking also often requires good lighting to work its best, which becomes another outside factor that has to do with what the analysis sees through the user's camera. Now, I plan to fix the camera-related issues through implementing a extra calibration step before assessing the analysis part of the program. This will calibrate the resolution, aspect ratio, and will help the user set up the camera uh, so that the analysis will work its best and inform the user to use good lighting on themselves and to try to keep the background clear if possible. And this will make sure that the analysis is at its most accurate. Another problem with the camera is the camera quality and the warp. For example, like the warp that fisheye lenses can provide or can have. Sometimes quality can be so awful that the analysis does not properly pick up the points, or maybe the lens of the camera is warped, which can slightly affect the accuracy of the analysis as it's not like one-to-one with real life. These problems are much harder to address and would probably be much more of a hardware limitation rather than a software. Now, another problem is the feedback system, which I currently have, and it is just not quite specific enough to really maximize the benefits that this application could bring. The current version of the program just measures the posture of the user, and then gives feedback regarding whether or not the posture is correct, but not really giving objective feedback on how to truly go about fixing the posture in the best manner. What I plan to do is to give much more tailored feedback to the user based on the analysis. For example, when doing a plank and the angle measure between the shoulder, elbow, and the wrist is higher than it should be, the feedback should come back as, for example, pull your elbows inwards or something of that nature. Just giving back feedback that is much more objective and helpful for the user. Now, this leads to one of the most undermining problems for the reliability of the program, which is that the motion tracking can at times be inaccurate. Sometimes the tracking does not keep the key points stably where they should be and would jump around for a short period of time. And this would obviously heavily decrease the accuracy of the program and it is often in large part, and actually in large part due to things such as previously talked about bad lighting, bad camera angle, background objects, which can interfere with the user's movements from the camera's perspective, etc. A large part and a large part of the solution to this problem comes from like solving for the issues with the camera and adding that extra calibration step, like I said earlier. But beyond that would be tweaking the inputted angles further and maybe experimenting with the best camera positioning relative to the user for each different exercise. Now, this carries over to what I call the two-arm dilemma, where the accuracy of the programs is at times jeopardized when utilizing two arms or legs for the analysis. As the analysis is taken at a side view of the user, um, when using, for example, two arms and a bicep curl, the analysis program might have trouble discerning between which arm to actually track. And then here in this image, you can see that the right shoulder and elbow is aligned properly on the shoulder and elbow that it should be on. However, if you look here, the wrist, it's actually locked onto the left arm, which it should be locked right here onto the right arm. And this happened quite often when you're using both arms. And often enough to a point where it is a genuine problem that undermines the accuracy and reliability of the entire program. Currently, my thought on how this could be fixed is that maybe there is a better type of camera positioning which can be used to avoid this problem for certain exercises, or just using one arm and getting the angle down for that one arm and just replicating it for the other. But that would be largely inconvenient for the user, and even inconsistent at times. This could be a problem that would require quite a drastic change in how I go about correcting posture through this means of motion tracking. And then just general future improvements I would add, just adding more exercises, um, and better user interface and ease of use for the user. And then in conclusion, this project really just started from a random idea I had when I was struggling with my posture in an exercise, and it was just super hard to get it right. And it has been quite a journey to attempt and bring this idea to life. There are still many things that I would love to improve on, but this project has improved my knowledge of coding and exercising posture by large margins and has been an ex amazing experience overall. Once again, I am Zhiyao. I go by Lucius. I'm a student at Los Osos High School, and that's my email if someone wants to contact me. And I hope everyone enjoyed. Thank you so much.